Okay, this lecture is over effect sizes. There is no real PowerPoint over effect sizes. Maybe in the future I'll put one together. But for right now, I have all the information that you need to know about effect sizes um, built into the example worksheet, if you will. So you have your final project worksheets right over here regarding the single sample, independent, paired, and chi-squared. And then we have this fun little thing on assumption testing that has all of the assumptions that need to be tested. We've got your data, and then once you get into everything, you've got your single sample reference, your independent reference, paired reference, goodness of fit reference. So let's talk about what an effect size is. An effect size is essentially, it's a measure of how practically significant the result is. So you're doing all these hypotheses testing, and you're like, hey, I've got these results, and these results are saying that I've got something. I've got something. And you get these significant results. It says there is a difference between this sample and this population. This is the difference that we have. It is statistically significant, and so therefore we should report it, right? Well, sort of. We do have something. We have data that says, hey, this sample is different than this population, or this sample is different than this sample, or the difference between this difference score is statistically significant, and that's all well and good, but the real question is so what? So it's different. Is it really even noticeable, the difference? I was in a meeting a little while back, and it was a meeting at a larger company, and they were talking about the different advertising strategies that they were using, and I noticed that they were using particular statistical techniques that really capitalized on the smaller nuances of the population that they were seeking. So there were these minute differences between these different groups, and for them it made a really big difference because it's like this group needed this and this group needed that, and it's just this tiny little differences that made all the difference in the world to them. And so for some people it's a big deal, but for other people it's like, yeah, there's really not that much of a difference. And so even though you noted that there was a difference, you really shouldn't say that there's that much of a difference. And the reason why is because you need such a large sample size in order to say that there's a difference, that there's pretty much no noticeable difference. It's if you look at it from a very, very backed up massive scope where you have a massive sample, then you're able to see that there's a difference. So let's take a look at what that means. So effect sizes. For each test, there is a different formula to calculate an effect size, or to calculate the practical significance. So you're going to get practical significance, and it is either going to have a small practical significance, medium, or large practical significance. And so for each one of these, they have a threshold for saying small, medium, and large. And so for the single sample, independent sample, you notice it's right here, down here, paired sample, right here, they all use the exact same measure, which is referred to as Cohen's d effect size. Now, with Cohen's d effect size, even though they're all the same, the formula is slightly different based on the test that we're using. Notice with the single sample, you have the absolute value of the mean of sample 1 minus the population over the standard deviation. For independent, you've got pretty much the same thing, mean 1 minus mean 2 over the standard deviation of the two pooled. And then this one right here, you've got the absolute value of the mean difference score over the standard deviation. And so what this says is, it takes into account the difference between what you're comparing and also the standard deviation. It says based on these two items that you're comparing, based on the difference that you're looking at, and based on how spread out your data is, we're going to be able to tell you whether or not your data is, this difference that you claim to have, whether or not it's very noticeable, somewhat noticeable, or barely noticeable at all. Okay, so if you have a small effect size is when you would barely notice the difference at all. Okay, so for instance, if I were to say to you, hey, I want you to look at the women's softball team, and you look at their GPA as compared to the women's soccer team. And if I were to ask you to look at that, I would assume that, maybe one of the two of them is going to be higher, uh, but you would barely be able to tell the difference. Like, if you look at somebody's GPA, you wouldn't be able to say, oh, that's definitely a softball girl, or oh, that's definitely a soccer girl just based on their GPA. And so it would be a very small difference, and you would need a very large sample size in order to be able to even tell the difference. Um, a medium effect size. A medium effect size is when the difference would be somewhat noticeable, but not huge. So maybe we'll look at women's volleyball players as compared to women's softball players, and look at the heights compared between the two of those. You would note that the women's volleyball players, they are taller, but is it really that noticeable? If you put all of the women's volleyball players and all of the women's softball players in the same room, just by looking at their heights, would you be able to tell the difference between the two? Would you be able to take a look at one of them and you would say, hey, just based on your height, I know that you're a softball player? Or just based on your height, I know that you're a volleyball player. So, a large effect size would be you put the women's volleyball players in the same room as the Olympic gymnasts. You're going to be able to look at any one of them and say, hey, I know you're a volleyball player, or I know you're a gymnast, purely based on your height. And that would be a large effect size. You would need a very small sample in order to be able to tell the difference. And so that's the difference between small, medium, and large effect size. And this is really important and also very underutilized in research in business. You know, it's very underutilized, and it's a big deal. Say for instance that you are running a computer company, and you're like, hey, we need i9 processor. And then you look at a few other different processors. You look at like an i7, an i5. You look at just different specs between all of these processors, and then you're like, hey, you know what? I think we really need to be going towards just making sure that we've got the best of the best, and let's stick with that i9 processor, and let's make it happen. Let's roll that out, and buy that i9 processor for everyone for their computers. And if y'all don't know what an i9 processor is, they're very expensive, and they are really solid, and very useful. However, it really isn't beneficial for the average business person to have an i9 processor with 8 cores. And so when you look at the productive difference between an average employee with an i5 processor with 4 cores, and then you have that same person with an i9 processor with 8 cores. If you look at the production and the productivity of those individuals, it would be very difficult to tell the difference. So that's a small effect size, and you're like, yeah, but they're going to be able to do so much more with this such amazing computing capacity. But you realize, yes, they could do so much more, but this particular clientele won't be able to do so much more because they're really not using it how it's designed. And I'm just gonna throw a little shade here. It's the same thing with MacBooks, right? MacBooks, you have all these individuals that buy these MacBooks, and they're like, hey, I'm going to use this. I'm going to be so much more efficient. It's not going to crash. I'm going to be able to, use it for what it's good for. And what we don't realize is that Macs are definitely very good for certain purposes, especially, those higher end MacBook Pros. But for all intents and purposes, the majority of students could get by with a $200, a $200 to $300 average PC, and the $200 to $300 average PC actually has more computing power than the majority of MacBook Airs and whatnot that are running around on campus. And so you have a small effect size. You're like, hey, I'm going to get a MacBook because it's going to make my efficiency at college so much better. So that's a small effect size, even though, you might be a little bit more efficient on a MacBook, even though you might be a little bit more efficient with a higher end processor. The truth is that spending all that extra money for an individual with average computing capacity is really not that beneficial. So that's the deal with a small effect size. And then last but not least, I'm going to show you guys really quick. We're not going to go over this super much, but right now at least, Kramer's V is the last effect size, and Kramer's V is specifically for goodness of fit for equal and unequal proportions. And we'll get into that a little bit more. Same thing, it's got a small, medium, and large effect size. So just be aware that these exist. Each one of these have their own formula. They take into account, the difference of what it is that you're looking at and how spread out the data is. And so based on those metrics, it's basically saying, hey, I can tell, how practically noticeable this is. I can tell how practically noticeable your results are based on, the difference and how spread out your data is. And so that's what a Cohen's d is. And then this right here, it looks at some other stuff, and we'll get into that a little bit later that it considers.